If we look at the code I've written so far, you can see that it's structured in a sequence of one Python statement after another. It's very repetitive in that blocks of the same steps are done each time. Print a species name, get some input, and then store in a variable. Now this is okay for now, but consider what would need to be done if I wanted to include another duck species in my survey. I'd need to repeat this basic block of code and then include the new species count in my calculation. That's quite a lot of code changes for something which seems simple in practice. And of course, with each change we make, the chances of introducing a new bug increases. It makes my current code seem brittle. If you recall from earlier when we looked at the types of data we needed for the surveys, we'd come up with the idea of using lists to record things. Lists of strings for the duck species and lists of integers for the duck counts. So let's see how we can introduce the idea of lists into our code. We'll do some examples in the Python console first. Now a list is simply a sequence of values. Usually they are of the same type, but in Python they don't need to be. Here's an example of a list of integers. I'll call the variable numbers and assign the list of values like this. Notice that the list of values is enclosed inside of square brackets. If I type numbers, you'll see that it's a list. Here's another example, but this time it's a list of strings assigned to the variable words. So we've seen how to create a list and assign it to a variable. But what about getting a value from the list, such as the second number from our numbers list? Well, in Python we use an index position to do this. It's written inside square brackets like so. Now you might expect that if I type numbers 2, I'll get 9, as 9 is the second item in the list. But in fact I get 4, the third item. That's because the index is really an offset from the beginning of the list. So the first item has a 0 offset, the second has an offset of 1, and so on. So to get the second item I need to type numbers 1. Of course, indexes have to be an integer. Now getting this wrong is one of the most common bugs in coding, so try to remember that the index is an offset. We can change the value in the list by assigning a new value to it using the index notation. So numbers 2 equal 42 changes item 3 from 4 to number 42. Let's add some lists to our code. I'll put the new code at the top of the file, and the first duck types is a list of the species of duck as strings. The second, duck counts, is a list of counts as integers. Each item in the list corresponds to the duck type. I've set all of them to 0 initially. Now let's change the print in input so that they use our lists rather than the individual variables. The first print ida changes to print duck type 0. So what this does is to get the first value from the duck types list, which is the string ida, and print it. In a similar way, we change the ida count variable to duck count 0, which will update the first value in the duck counts list. Notice that pie chart is showing that we have a problem. Double-clicking on the problem takes us to the line in question. As you can see, it's because we're still using the now removed ida count variable in our calculation. So change this to duck count 0 to fix the problem. Before going any further, let's run our program to make sure that it works correctly. OK, the word ida is appearing, so it's coming from our list OK. Now enter the values 0 to 9 for the counts. The total's 45. That's the same as before, so everything looks fine. Let's change the rest of the code to use the two lists. I'll change gadwal to duck types 1 and gadwal count to duck counts 1, both for the input and for the calculation. I'll speed up the video a bit and continue to do the rest. OK, I'll check to make sure that I've got the indexes correct and then run the code to test, entering 0 to 9 as before. That's good. The duck types print OK and the total is 45 as expected. So we've removed loads of variables and replaced them with lists, but my code's still very repetitive. It's repetitive because I'm basically going through lists of things in sequence. In programming, this sort of repetition is solved by the use of a loop. Now, a loop surrounds the statements you want to execute with the means of controlling the number of times you want to do it. You can control the number of times by either counting or by checking some condition that, if true, stops the looping. In our example, the number of times we want to get the duck count is 10, one for each of the species. In programming, there are two main types of loop, for loops and while loops. For loops are used when we want to loop through a set of things, such as a list of numbers, and when the number of things is known. A while loop, on the other hand, runs while an expression is true and stops when it's false. I'll show some examples in the Python console. I'll start with the while loop and write some code which counts down the numbers from 5 to 1. First, I create a variable called counter and assign the value 5 to it. Of course, the variable could be called anything, but counter is a good name. Next, I write the while statement. It's made up of the keyword while and a condition, which in this case is a check to see if the counter is greater than 0. Next is the thing that I want to do. Here it's just to print the value of the counter. Notice how the statements inside the while loop are indented. This is how Python knows that this code is part of or inside the while loop. We'll come across code being indented a lot as it's a key part of Python. Finally, and this is vital, we have to do something to the counter so that eventually it reaches 0. If we don't, then this loop will run forever since the counter will always be greater than 0. Of course, to do this we just subtract 1 from the counter and reassign it like so. Well, that's it. To get the Python interpreter to run our code, I just press backspace to remove the indent and then enter. There you go, a count down from 5 to 1 using a while loop. So looking at the code again, it works by first setting the counter to 5, then a while loop which goes round while the value of counter is greater than 0. The code indented under it is what gets done on each loop, namely printing the value of counter and then subtracting 1 from the counter. Or another way of saying this is decrementing the counter by 1. Let's have a look at the for loop now and see how we could print out the numbers from 1 to 5. The first way is to have a list of integers arranged from 1 to 5 and just print them out. We then write the for statement like this. What Python does in this case is to take an item from the numbers list starting at the beginning, here that's the integer 1, and assign it to the variable number. It then executes the code in the block inside it, here that's to print the value of number. Now assuming that it's not the end of the list, it moves to the next item, the number 2, and repeats the whole process again. This continues until it reaches the end of the list. Now if I run this block of code, you can see it prints correctly. Of course, the code isn't really counting as such, it's just printing out the numbers I've made up. This first method of using the for loop is great when you just want to read items from a list. Another way of using a for loop is by using an index into the list. In this example, we have some numbers that I want to change by multiplying each number by 2. First, I create the list of numbers. Now the for loop here uses a Python built-in type called a range. Its job is to take a number that you give it, like 5 in this case, and turn that into a sequence of numbers. This sequence usually starts at 0 and finishes at 1 less than the number you give it. So a range of 5 turns into a sequence of numbers 0, 1, 2, 3 and 4. Now, typically you use this sequence as indexes into a list. So here the variable index gets in turn the value 0 to 4. The next line of code is what gets executed inside the loop. It gets a value from the numbers list using the index, multiplies that by 2 and then assigns the answer to the same point in the list. So the first time the loop executes, the index is 0, which is used to refer to the first item in the list, which is the number 5. 5 is then multiplied by 2 and then stored back as the first item in the list. So if I run the code block and then type numbers, I see that each of the values in the numbers list has indeed been multiplied by 2. And let's change our code to make use of loops rather than everything being sequential. If you recall, I want to use the duck types and duck count lists together in such a way that I move through the lists printing the type and then updating the counts with whatever is input. If we look at this block of code, it seems to me that if I replace the 0 index with an index from a for loop, then I can do all of my inputs in a few lines of code. So using the same sort of pattern that I just did in the console, let's use a for loop with a range. Now range needs a number which is the size or length of the lists. Since I know that there's 10 duck types, then I can type for index in range 10 to give me a range from 0 to 9, which gets assigned in turn to the index variable. Then I want to move the block of code into the loop. Select the block of code and then cut it. Then press enter at the end of the for statement and paste the code inside. Next, change the 0 to the index. Now let's just check this once more before going further by executing the code in our heads. We're creating a range 0 to 9, then in the first loop index gets a value of 0. We print out duck type 0, which should be IDA, then get some input, then update duck count 0 with that value. That gets repeated with indexes up to and including 9, which is the offset for the end of the lists. Now the blocks of code under here are not needed, so we can delete them. However, if I've made a mistake, then I'll have to retype everything, so for the moment we'll just comment out that code. So select it all, then go into the code menu and click comment with line comment. Now PyCharm kindly comments out all of the selected code. Of course, after I've proven that my code works, then I'll just delete all of this. Okay, let's test our code by running it using the same duck counts as before. As you can see, the species names come up in order and the total is correct, so it looks like our loop is working fine. We can delete the commented out code now, and you can see how our code looks a lot smaller and there are less things to alter if I want to say add an extra duck species. The calculation for the total duck count looks brittle as well, and it could be done as a for loop instead, so let's do that. The total duck count is just the individual counts added together, so first initialize the total count with 0, and then write the for loop as before, but this time in the block of code inside add the total count to the value in the duck count list, and then assign this back to the total. Now a quick check by running the code in our heads. In the first loop total count is 0. This 0 is then added to the first count from the list, let's say it's 2. So the total count is now 2. Then on the next loop we add the next count from the list to 2 and so on. That seems okay. Let's comment out the old calculation as well and add a comment above our new code. Run the code and enter the values as before. It's 45 again, so our calculation seems to work okay. Finally, delete the commented out code. Our code looks a lot cleaner now, but is in a sense more complicated as it's using more parts of Python's language. But like any language, once you learn how to speak it, even the hard parts become easy. Well, that's it for the moment. We've learned more about the Python language by using lists and loops, and have used the built-in range type to produce a sequence of numbers that we can use in a loop. We've used the Python interpreter to write blocks of code and learned how to comment out multiple lines of code using PyCharm. In the next video we'll introduce the idea of functions or subroutines, which we'll need to know about before adding more features to our duck survey application.